Today's lesson is on inscribed angles and using them in inscribed polygons. An inscribed angle is an angle whose vertex is on the circle and sides are chords of the circle. An inscribed angle can extend beyond the circle as a ray, as a line, or it can be in the circle as a chord. The intercepted arc is the portion of the circle between the two lines, rays, or segments. If the endpoints of a chord lie on the sides of an inscribed angle, then it is called subtending the angle. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. If two inscribed angles intercept the same arc, the angles are congruent. In a right triangle, if it's inscribed in a circle, the hypotenuse would have to be the diameter, and the angle would of course be a 90-degree angle. If you can inscribe a quadrilateral inside of a circle, then the opposite angles have to have a sum of 180, both pairs of opposite angles. If a polygon is inscribed in a circle, then the circle follows that you could draw a circumference around the polygon so it intersects at each of the vertices. In our first example, we're finding the measure of the arc and the angle. The measure of the arc is twice the measure of the angle. The measure of the angle is 1/2 the measure of the arc. In our next example, we're finding the measure of the arcs. The measure of arc HML has a measure of twice as much as 109. So if we double 109, it's 218 degrees. Arc HJL, angle HJL, that is, first, angle HJL has the same arc, so it's congruent, 109. So the angles are congruent. Given the measure C equals 68 degrees, find the measure of angle B. Again, notice that they have the same intercepted arc. Therefore, the angle B is the same measure, 68 degrees. And the arc would be double the angle. So if we double the angle, our arc is 136 degrees. The angle is 90 degrees. Set 5x equal to 90. Divide by 5. Our angle is 18. On the next example, the opposite angles have to be supplementary. (65 plus b) has to equal 180. If we take 180 minus 65, we get 115. So b equals 115. Same with the other two angles. 3a plus 111 equals 180. Subtract 111 from both sides. We get 69 for 3a. Divide by 3. A equals 23. You have a 90-degree angle. You want to photograph the front. You stand at a location in which the front is all that appears. You want to change your location. Where else can you stand? So the front is all that appears in your camera field of vision. So as long as this is, so think about our arc. We can stand, here would be kind of the intercepted arc. If we think of this as a diameter, we can also put a circle around it, so I'll show you that. First we have to move the circle where it goes. Well, my attempt at a circle didn't work so well, but we could kind of get the idea of where we would have to go in order to draw a circumference around it so that we were at a 90-degree angle and standing around.